Alright guys, welcome to your last day of notes for the semester. We're going to talk about adding and subtracting rational expressions day 2. So this is and subtracting, not just adding, because they're essentially the same thing. So let's look at some examples. Now, we did adding and subtracting yesterday, and it was dealing with common denominators. So we still have to do the same thing, but if I look at this, it's kind of tougher to figure out what the common denominator between these two are. You can't just be like, oh, it needs an x squared, and then it needs an 8x, and then plus 12. You can't really do that. What you have to do is we have to multiply it by something. In order to figure that out, we have to factor out this one on the left-hand side. So, what multiplies to 18 but adds up to 9? Well, that's just 6 and 3. So we can write this as x plus 6 and x plus 3. And I'm going to go ahead and kind of just cross this off because I really don't need it. I'm going to use this x plus 6, x plus 3. Now if I look, this has an x plus 6 and an x plus 3. This side only has an x plus 6. So it's going to need an x plus 3. So I'm going to multiply the bottom by x plus 3. Okay, if I do it to the bottom, I have to do it to the top. Okay, just like we did yesterday. Now, the left side doesn't need anything, so we're just going to go ahead and rewrite what we have. We have 3x plus 5 over x plus 6, x plus 3, and we're just going to keep it just like that. And then plus, now we get to multiply this out. So x times x is x squared. X times 3 is 3x. Then I have plus 7x. Then plus 21. Oops, 7x plus 21. So we just multiply that out. We distribute it out. And then it's still just over x plus 6, x plus 3. Now that I have common denominators, now I can combine like terms. So I have nothing to match with the x squared, so I'm going to go ahead and have x squared. Now I'm going to have a 3x, a 3x, and a 7x. Well, 7 plus 3 is 10. Plus 3 again will be plus 13x. And then I have this 5 with this 21. 5 plus 21 gives me a grand total of 26. Okay. Now that's over x plus 6, x plus 3. Now the very last thing I need to do is see if I can factor this out. This is like the very last step. So let's just think, is there anything that multiplies to 26? And that adds to 13. Well, it's just really 2 and 13. Well, that doesn't add to 13, and 1 and 26. Okay, so there isn't anything there, so this is just going to be our final answer. Okay, 9 times out of 10, we really can't factor it, but you always just got to double check. Now, if I look at this one, same thing. We have the x minus 2, x minus 3. Before I can figure out what I need to multiply the bottoms by to get common denominators, we need to factor this out. Okay, so we're going to go ahead and factor out what multiplies to 6, but adds up to negative 5. Well, that's negative 3 and negative 2. Okay, so we're going to have x minus 3, x minus 2. And so now if I look, well, this middle one is missing an x minus 3. So I'm going to have to multiply by an x minus 3. If I do it to the bottom, I have to do it to the top. Okay. And this one's missing an x minus 2. Okay, and I have to do that x minus 2 to the top. Okay. Now, let's go ahead and rewrite what we have. Well, I don't have to do anything with the 5x squared. Okay. So then we're going to have the x minus 3, x minus 2. Okay. Now, you can either do this at this step, or if we just realize this is a negative or a subtraction, so I need to change this to a positive and change that to a negative 2, and then I can just distribute. So I'm just going to go ahead and put a plus there now. So I'm going to have negative 2x. Negative 2 times negative 3 is a positive 6. The big thing is giving that subtraction to both of them. That's where people make their most mistakes, is that part right there. So I have x minus 2, x minus 3. And then the last one, multiply this 3x to both of those, so we're going to have 3x squared minus 6x all over x minus 2, x minus 3. Okay. Now we have common denominators, so let's combine like terms. We'll have a 5x squared and a 3x squared, so that's going to be 8x squared. Okay. We have a negative 2x and a negative 6x, so that's going to be negative 8x. And last but not least, we have a plus 6. All of this is going to be over x minus 3, x minus 2. And we can't really factor that top anymore, so this is our final answer. Now this one's kind of a tricky one. If we notice, this isn't written in the correct order, so let's rewrite this. This is negative x plus 4 if I rewrote it. Okay, I'm going to kind of cross that off because I don't need it anymore. Now, before I say, oh, okay, I need to multiply by different things, let's just think. Here's x minus 4. What can I take out of this? I can take a negative 1 out. And if I take a negative 1 out, I'm left with a positive x minus 4. Okay. Now, when we look at that, we say, okay, now I have an x minus 4's that match. This side just needs a negative 1. So I'm going to multiply the left side by negative 1. Okay. So I'm going to have negative 4 over negative 1 x minus 4 minus 2 over negative 1 x minus 4. Okay. Now when I go ahead and do that, I'm going to change it to positive and change that to a negative 2. So negative 4 plus negative 2 is negative 6 over negative 1 x minus 4. Okay. Now what if we think, hey, a negative over a negative is a positive. Okay, so this should really just be a positive 6, and then I really don't need a positive 1 down there anymore, over x minus 4. And that's my final answer. Alright, your exit ticket, how can factoring be helpful? Just think, we factor to figure out what our common denominator is. So when we have trinomials, or things that have 3 terms like the x squared or something x, so let's say 2x plus 1, we had to use factoring to be able to figure out what our common denominator will actually be.